Okay, so today we're going to look at section 2.5, applications of linear equations and modeling. The first thing we're going to do is we're going to look at our slope formula. The slope equals y2 minus y1 over x2 minus x1. Now let's do a little bit of manipulation here. Let's go ahead and multiply both sides by x2 minus x1. That'll give us x2 minus x1 times m equals y2 minus y1. Or to put it in a more traditional form, y2 minus y1 equals m times x2 minus x1. So let's go ahead and label point 2 as simply point xy. So now I have y minus y1 equals m times x minus x1. What this is called is the point slope formula. Where m is the slope and x1, y1 is a point on the line. Okay, so let's look at this. Real simple. So we're going to use the point slope formula to find an equation of a line passing through the point -5, 2, and having slope -3. And we want the answer in slope-intercept form. So we simply have y minus y1, which is 2, equals m times x minus x1, which is -5. Oh, we know our slope. -3 is our slope. So now I have y minus 2 is equal. We distribute this -3, -3x minus 15. Add 2 to both sides. Y equals -3x minus 13. That is the slope-intercept form of that line. Okay, life would be easy if we were always given a slope and a point on a line. However, what if I'm given 2 points? Say 2, -5, and 7, -3. So what can I do here? Well, I have 2 points that are on the line. So I have the point portion. I need the slope. Since I have 2 points on the line, I can calculate the slope. The slope is equal to y1 or y2 -3 minus y1 minus -5 over 7 minus 2. This is 2/5. So that's my slope. Now I have a point. I could pick either one. Let's go ahead and use this one. So now y minus a -5 is equal to my slope 2/5 times x minus 2. So I have y plus 5 is equal to 2/5 x minus 4/5. I can subtract 5 from both sides and I get y equals 2/5 x. 5 is 25/5, so I have minus 29/5. And that is my equation. Okay, so now let's talk about slopes of parallel and perpendicular lines. So if M1 and M2 represent the slopes of two non-vertical lines, then M1 equals M2. And the reason they can't be vertical lines is because if you remember, vertical lines do not have a slope. So essentially what this is saying, if I have two lines and they're not vertical, they have the same slope, they are parallel. Non-vertical, that's where I forgot, parallel. So two non-vertical lines that are parallel will have the same slope. If M1 and M2 represent the slopes of two non-vertical perpendicular lines, then M1 equals -1 over M2, -1 over M2, or M1 times M2 equals -1, or M2 equals -1 over M1. So again, we have to take into account that that neither of them is vertical because there's no slope in the vertical line. So if we can multiply the slopes together and we get -1, we have perpendicular lines. If the slopes are equal, we have vertical or parallel lines. So write an equation of a line passing through the point -3, 2, parallel to the line x plus 3y equals 6. And it says write the answer in slope intercept form. Okay, so first thing we need to do, we're doing parallel, so the slopes are going to be the same. So we need to calculate the slope. So let's go ahead and subtract x from both sides. Then we need to divide by 3. Then my slope, and we'll do this, -1/3 times x plus 2. So my slope is -1/3, talking parallel. So we want the same slope. Now using my slope intercept formula, I have y minus y1 equals m times x minus x1. I have y minus 2 equals -1/3 times x minus a -3. So here I have y minus 2 equals -1/3 x minus 1. I'm going to add 2 to both sides, and I get y equals -1/3 x plus 1. Now there's another thing to take into consideration when looking at parallel lines. The y-intercept has to be different. Because if it's the same, then they're not parallel, they're the same as that line. Now let's look at perpendicular. So write an equation of a line passing through the point -8, -4, perpendicular to the line, y equals 1/6x plus 3. So my slope of this line is simply 1/6. So the slope of my perpendicular line is 6. So I have a slope and I have a point. So I have y minus y1 equals m times x minus x1. I have y minus a -4 equals 6 times x minus a -8. So y plus 4 equals 6x plus 48. Subtract 4, y equals 6x plus 44. We made a mistake, didn't we? Negative. Don't forget the negative. Remember, m1 times m2 equals -1. So take the reciprocal and switch the sign. Okay, so now let's look at some applications of this. So a speeding ticket is $100, $100 plus $5 every mile over limit. Now write a linear function to model the cost. I'm going to say S of X in dollars of a speeding ticket for a person caught driving X miles per hour over the speed limit. So there's that $100 charge plus $5 for every mile per hour over the speed limit. Then it says to evaluate S of 15. So S of 15 equals 100 plus 5 times 15, which is 100 plus 75 is $175. That's simple. So now let's look at cost, revenue, and profit functions. So we have a cost function, which models the cost, C of X, to produce X items. Typically, we're talking C of X equals mx plus b, where m is the cost per item and b is the fixed cost. In other words, the startup cost. If you were starting a business, this would be the rent, the utilities, the lease on the property, and all that. That would be your startup cost. Okay. A revenue function, or linear revenue function models revenue R of X. We're selling X items. And typically this is R of X equals P times X. Where P represent the price per item. And lastly, we have profit function. This models the profit for producing and selling X items. Typically, this is P of X equals the revenue minus the cost. So let's see if we can't do an example of this. So at a summer art show, vendor sells lemonade for $1.50 per cup. So P is $1.50. The cost to rent the booth is $100. This is the startup cost. So B is $120. Okay, and furthermore, the vendor knows that the lemons, sugar, and cups collectively cost 40 cents for each cup. So that's in our price per cup, or our cost per cup, which is M. So M is 40 cents. So first thing we want to do, write a cost function to produce X cups. So we're looking at a cost function. C of X is equal to MX plus B, where M is the cost per cup of 40 cents times the number of cups X plus the startup cost B. Next, write a linear revenue function for selling X cups. So our revenue is P times X, which is $1.50 times X. And then write the profit function. The profit function is simply, this is where you have to be careful. C of X minus, or R of X minus C of X. See, I told you had to be careful. R of X minus C of X. So this is R of X 1.50X minus C of X 0.40X plus 120. Remember to distribute this negative to both. So now I have 1.50X minus 0.40X, 1.10X, and this becomes minus 120. So that's my profit function. How much profit will the vendor make if 50 cups of lemonade are produced and sold? So now I want to know P of 50, which is 110 times 50 minus 120. So we have 110 times 50 minus 120. So this is 55 minus 120, which is negative $65. So it's a loss of $65. How much profit will be made for producing and selling 128 cups? So now we're looking at P of 128. So I have 1.10 times 128 minus 120. 1.10 times 128. That's 140.8 minus 120. That gives me $20.80. So we have a profit of $20.80. Last, what is the break-even point? So that means I want my profit to be 0. 1.10 x minus 120. So I add 120 to both sides. Then I divide by 110. And I get 1.0909 repeating. So roughly, approximately 109 cups. Okay. So let's look at something else now. Suppose that Y represents the average customer spending on television services per year in dollars, and X represents the number of years since 2004. So we're going to start with the data points 2, 308, and 6, 408. I'm going to write a linear equation relating to X to Y. So we need a slope. And we'll call this 0.2 and 0.1. So I have y2, 6 minus y1, 2 over x2, 408 minus x1, 308. I have 4 over 100 or 1 over 25. I have my slope now. And I have a point. I can pick any of them. I'm going to go y minus 308 equals 1/25 of x minus 2. So y minus 308 equals 1/25 x minus 2/25. Oh, wait a minute. Yeah, we did this backwards, didn't we? That didn't make sense. Y2 minus y1 over x2 minus x1. 100 divided by 4, 25, much better. So now we have y minus 308 equals 25 times x minus 2. We have y minus 308 equals 25x minus 50. Add my 308 to this, and I get y equals 25x plus 258. Interpret the meaning of the slope in context of this problem. So what did X represent? The number of years. And what was Y? Y is the average consumer spending. So this is telling me that the average consumer spending is positive, so increases by $25 every year. The y-intercept, interpret the meaning of the y-intercept. The y-intercept is saying $258. So at time 0, which was the year 2004, the average spending was $258. Use this model to estimate the average consumer spending on television services for the year 2007. So 2007 is what, 3 years from after 2004. So we simply let x equal 2000 or equal 3. We have 25 times 3 plus 258. So 75 plus 258 equals 2, not 2, 3, 333. And that is it. Now the next thing we're looking at is called a least squares regression line. And there's a way to do this by hand, but we're going to learn to do it by calculator. So theoretically, we would graph the data in a scatter plot. We would inspect it visually to determine if the data suggests a linear trend. We're going to assume that in anything we do. Then we're going to invoke the linear regression feature on a calculator, graphing utility, or spreadsheet. And then we'll check the results by graphing the line through the data points. So again, we're strictly using our calculator. So we'll start with this. We have the number of absences. This is always an interesting problem. Data given below represents the class averages for individual students based on the number of absences from the class. And then the average in class. Okay, so here's our data. We got a 3 and an 88, a 7 and a 67, a 1 and a 96, an 11 and a 62, a 2 and a 90, a 14 and a 56, a 2 and a 97, and a 5 and an 82. So now we have our data. So we want to find the equation of the least squares regression line. So here's what we do. Turn on your calculator. First up, hit the stat button. We want edit. So if you have edit highlighted, hit enter, and then you're going to see the L1, L2, L3 again, as we saw before. Getting some old data out of here. Okay, so now go through and we're going to enter X values in L1. So at the top, hit 3 and then enter. And then just continue doing that till you get to 5 and enter. So 3 enter, 7 enter, 1 enter, 11 enter, 2 enter, 14 enter, 2 enter, and 5 enter. Then we're going to arrow across, which should bring us up to line 2. And we're going to key in our line 2 data. 88, enter, all the way to 82, enter. I have 88, 67, 96, 62, 90, 56, 97, 82. So now we have all that in there. Next, we're going to hit second and trace. Then we'll hit the second button. Then we'll hit the trace button. If you notice above trace is the word CALC, calculate. Now, so we want to calculate, and what we're looking to calculate is, oops. Actually, that's wrong. Try this again. Then we're going to hit stat again. Then we're going to arrow over so that we're at CALC across the top. Then we're going to arrow down until we reach, on my calculator, it's 4. It's LINREG AX plus B. So we go down to that and hit enter. This should show on your screen, and hit enter again. And when you do that, it should say LINREG, and I get y equals AX plus B. It says A is equal to negative 3.270248597, and B is equal to 98.14514.836. So what this means is my least squares regression line, least squares regression line is y equals A, -3, and let's just round to 4 decimal places. So negative 3.2702 times x plus b, 98.1451. That is my least squares regression line. Or regression line is what it tends to be referred to. Now the next question is, use this model to approximate the average for a student who misses 6 classes. So now we're going to say x equals 6. So y equals negative 3.2702 times 6 plus 98.151. So we do our calculations. 3.2702 times 6. This gives me negative 19.6212 plus 98.1451. And I get 78.5239. So let's look at this a little bit. This is kind of interesting. First thing to note, what we're saying is for every day absence you have, your grade should be expected to decrease by roughly 3 1/4 points. And here's the other thing that's interesting. If you have no absences, your grade's expected to be roughly a 98. So this is how regression works. So regression can be used for a lot of things, and there's a lot of different types. It's not just linear. But in here we're only going to mainly look at linear. We'll touch on a couple others later on. But I will tell you this, there is a test question on this. So do make sure you understand how to do this. You can do it on your own without notes. And if you have any problems, email me, contact me in some fashion, and we'll figure out some way to go over it, perhaps a Zoom meeting. So that finishes up 2.5. Have a good day, and I will see you next time.